out that you hear me and see the board okay? Okay, here we go. All right, so guys, the last inverse trig function will be the inverse cotangent. He's probably going to be the worst one for you just in the sense that he doesn't behave like his reciprocal inverse tangent, but we'll be able to fix that. All right, so guys, just again to kind of cut corners a little bit and save a little bit of time and hopefully give us more time practicing examples, instead of us cutting the graph ourselves and creating the inverse graph, I kind of did that for you already. So here is the graph of cotangent. We need it to be a one-to-one function in order to make that inverse be able to exist. So since we can't use the whole graph isn't one-to-one, we have to take a portion of it. So we actually end up taking his first cycle, just like we took the first cycle of tangent. We're going to take the first cycle of cotangent, which goes from 0 to pi. So those are going to be the angles that survive the cut of the cotangent graph, but then the ratios are also infinite. They go from negative infinity to infinity. So all the ratios survive the cut, but only the angles from 0 to pi. We're just keeping this portion right here. So when you take this portion and create the inverse, you get this graph. Angles from 0 to pi are going to be capable of coming out as the y-coordinate of the inverse cotangent, and then ratios from infinity to a negative infinity can go in. All right, so if you look at how his inverse works, looking at the inverse functions graph, all right, if I plug a ratio greater than 0 in, so if I plug a ratio from 0 or greater in angle between 0 and pi over 2 comes out. That's a quadrant 1 angle. So if you take the inverse cotangent of a positive ratio, it's going to spit out an angle in quadrant 1, which you could say, well, that's just like his inverse tangent, and it is. However, if you look at the rest of his graph, if I plug a ratio less than 0 in, if you plug a ratio 0 or less than that in, now an angle between pi over 2 and pi comes out of that function, and that's a quadrant 2 angle. So now an angle between pi over 2 and pi can come out of the inverse tangent, and that would make the angle in quadrant 2. So then if you were doing this by hand, I would draw an angle or a triangle in quadrant 2. So guys, the angles that survive the cut of the inverse cotangent are angles from 0 to pi, quadrant 1 or quadrant 2 angles. That's not like the inverse tangent. The inverse tangent had angles from pi over 2 to negative pi over 2 survive, quadrant 1 and quadrant 4. So that's going to create a little bit of an issue when we need to use the calculator for the inverse cotangent, because there's no button for him, but I can't use his reciprocal either because he doesn't behave the same way. They don't spit the same angles out. All right, but guys, so you can kind of say to yourself, is there an inverse trig function that he does behave like? Well, yeah. The inverse cosine spit out angles between 0 and pi, quadrant 1 and quadrant 2 angles. So guys, this one acts like the inverse cosine function. So that's why you'll see when we start doing an inverse cotangent problem and we have to use a calculator, it has to be converted to an inverse cosine problem because they're capable of spitting out the exact same angles, okay? All right, so here we go. Here's our cheat charts. So we saw yesterday, the inverse secant acted just like his reciprocal, and he spit out angles between 0 and pi. So he's going to be able to turn into inverse cosine problems, no problem, right? This one acts like inverse cosine. So he's going to have no problem being converted to his reciprocal trig function without a doubt. The inverse cosecant we saw spits out angles from pi over 2 to negative pi over 2, quadrant 1 and quadrant 4 angles, just like his reciprocal trig function. So he acts just like the inverse sine, which is awesome because it's going to be a very easy conversion from a cosecant problem to a sine problem. They're reciprocals. All right? But the inverse cotangent we just saw spit out angles between 0 and pi, which is not like his reciprocal trig function. He spits out quadrant 1 and quadrant 2 angles. So we just said it, he acts like the inverse cosine function. So he's going to be converted to inverse cosine problems, which is going to take a little work. Okay, So now, all of your reciprocals, right? If you take the inverse secant, the inverse cosecant, or the inverse cotangent of a positive ratio, it's going to spit out an angle in quadrant 1. All three of them will still spit out an angle in quadrant 1. But guys, remember the ratios. Only ratios greater than 1 or less than -1 survived the cut of the inverse cosine and inverse cosecant. So you can't plug in a ratio between -1 or 1 into the inverse secant or inverse cosecant. All right, and then all the ratios survived him, so he doesn't have a bad ratio. All right, if you take the inverse cosecant of a negative ratio, it's going to spit out a quadrant 4 angle, right? You plug in a ratio less than -1, it's going to spit out a quadrant 4 angle. All right, but then the inverse secant, if you take the inverse secant of a negative ratio less than -1, it's going to spit out a quadrant 2 angle. And then we just saw if you take the inverse cotangent of a negative ratio, and again, there are no bad ratios for him, it's going to spit out a quadrant 2 angle as well. Okay, here we go. Let's try some problems. Well, I got to fill, I think, one more thing in. And then. I'm very redundant. I make you write this a lot, so I apologize.
Helps me learn.
All right, yeah, that's what I do it for. All right, so therefore, the inverse secant has the same range. He is capable of spitting out the same angles, the same range as inverse cosine. Therefore, the inverse secant will be converted to inverse cosine problems. Great, nice easy switch. They're reciprocals. It's a flip of a fraction. All right. The inverse cosecant function has the same range, the same capability of the angles it can spit out as the inverse sine. So the inverse cosecant will be converted to inverse sine problems, which is great because they're reciprocals. It's the flip of a fraction. All right, and then the bad guy. The inverse cotangent has the same range. He is capable of spitting out the same angles as the inverse cosine. So the inverse cotangent problems, if it's a calculator problem, they're going to have to be converted to inverse cosine. He can't be converted to his reciprocal. They are not capable of spitting out the same angles. All right, I think I'm going to do this one first before I get to these ones. So I don't know if you have a spot somewhere you could just kind of smush this. Let me do one. These problems say use a calculator to approximate each expression in radians. Your homework is going to have questions just like this, but it's also going to have ones that say find the exact value of. Now, I did a few of them for inverse secant and inverse cosecant yesterday. I didn't do an exact value inverse cotangent, so let me just do one. So let's say you were asked to find the exact value of this. If you are asked to find the exact value, guys, it's a non-calculator question technically, which means it doesn't have to be converted to an inverse cosine or an inverse this, because if it's an exact value, you should be able to do it without a calculator just the way it's written. So let's say you were asked to find the inverse cotangent of -√3. Now, I don't know if you recognize that, but √3 is a special ratio for our special angles. Either it's going to be a pi/3, a pi/6, a pi/4, or a quadrangle, all right? So I would do this. Look at your triangles.
That's for the cotangent. That's for the cotangent problem. Just for now.
Yes, that's for this problem right here. All right, if it's a exact value, then it's one of our special angles or a quadrangle. Okay, so if you're taking the inverse cotangent of -3, guys, if you take the inverse cotangent of a negative ratio, we know the answer to this is a quadrant 2 angle. We already know that. It's some quadrant 2 angle, right? The inverse cotangent is capable of spitting out angles in quadrant 1 or quadrant 2. The ratio is negative. We know it's the quadrant 2 angle. So really, you're just trying to find out the cotangent of what special angle? It has to be a special angle if it's an exact value question, something you'd have to be able to find off the top of your head, had a ratio of -√3. Well, guys, forget the negative. Look at the √3 part. That's a √3 over 1. So now go to your triangles and find out which one, a 30, 60, 45, or maybe one of your quadrantals at your 0, 1, 1 zeros, okay? Who had a cotangent ratio of √3/1? Remember, cotangent was A over O. It's an X coordinate over a Y coordinate. So guys, if you come to 45, A over O would be 1. So it's not the cotangent of a 45. If you do a 60, the cotangent of a 60, A over O, is 1 over √3. We're getting closer. If you look at a 30, the cotangent of a 30 would be A over O. It's √3/1. Guys, it's totally a 30-degree angle that would have a cotangent of √3. But if it's negative √3, we got to figure out what quadrant it is. We already know it's quadrant 2. So it is some multiple of a 30, which is a pi over 6. So who's the multiple of pi over 6 that landed in quadrant 2? Guys, use your anchor. This is your 6th pi over 6. Who's the one that landed 1 pi over 6 before him? 5 pi over 6. So it is 5 pi over 6 that would be the answer to that question. That is the angle that had that cotangent ratio. All right, so again, if it says find the exact value, guys, it's one of these angles or some multiple of them, or it's a 0, pi over 2 pi, negative pi over 2. Those are the ones that survive the cut of your inverses, okay? All right, now everything else we're going to do on the calculator. Everybody okay with that? Okay. All right, let me move mine up. Let's do this. Okay, let's say you were asked to find the inverse secant of 3. Guys, we know the inverse secant is capable of spitting out the same angles as cosine from 0 to pi over 2. Now, that is not a special ratio. 3 is not one of our √3s, 2s, 1s, or anything like that. So it's not a special ratio. We have to use the calculator. Well, guys, there's no inverse secant button on your calculator. So we have to convert this to an inverse cosine, his reciprocal trig function who behaves the same way. Well, guys, that's easy. If the inverse secant is being taken of that ratio, then you would take the inverse cosine of the reciprocal of that ratio. So what's the reciprocal of 3? 1/3. So it's literally the flip of a fraction to create the inverse's reciprocal trig function. So now all I have to do is take the inverse cosine of 1/3. And guys, we know if you took the inverse secant or the inverse cosine of a positive ratio, it's definitely a quadrant 1 angle. The answer to this is a quadrant 1 angle. Now, because you're using your calculator, it's going to give you the decimal radian answer. So this is 0 radians, this is pi over 2 radians, and this is pi radians. 3.14 divided by 2 is 1.57. Pi is 3.14. So the calculator is going to give you some radian measurement between 0 and 1.57. If it's not a number between 0 and 1.57, it didn't give you a quadrant 1 angle, and it couldn't possibly correct. You might have typed something in wrong. So go to your calculator, take the inverse cosine. There's my calculator, there it is. Take the inverse cosine of 1 divided by 3, hit enter, and it's 1.23 radians. And that is definitely an angle between 0 and 1.57. It's definitely a quadrant 1 angle. So the answer to that is 1.23 radians. Now, you don't label radians. I just always like to put it, I want you guys to realize that that answer is an angle measurement. It's not a ratio. All right? Now, can we all make this? Go to mode, which is right next to the blue second button. Just make sure you're in radians. See how radians has this black box behind it? You'll want to be in radians, okay? You don't want to be in degrees. Otherwise, that's a whole different answer. All right? Second, quit. I'm in radians, so I'm good to go. All right, let's go back to the next problem. Where is the next problem? There. All right, let's say you have to take the inverse cosecant of -4. Guys, we know the inverse cosecant is capable of spitting angles between quadrant 1 and quadrant 4, pi over 2 to negative pi over 2. So definitely 1.57 to -1.57 radians, and that's 0 radians if you look at the decimal versions. All right, if we take the inverse cosecant of a negative ratio, we know it's spitting out an angle in quadrant 4, right? So we know the answer to this is a quadrant 4 angle, somewhere between 0 and -1.57. Well, guys, let's convert it to his reciprocal trig function, something we do have a button for on the calculator. So if that's inverse cosecant, he acts just like his inverse sine. He's capable of spinning the same angles out, except if this is the cosecant ratio, the sine ratio would be his reciprocal. So flip it over, negative 1/4. So now you have to take the inverse sine of negative 1/4. All right, ask your calculator. It better be a number between 0 and negative 1.57. Second inverse sine negative 1 divided by 4. Hit enter. It's negative 0.25 radians, which is definitely in quadrant 4, between 0 and negative 1.57 radians. Okay? All right, look at this one. The inverse cosecant of 0.8. You're probably going to get caught up with a math moment, which is fine. Something's wrong with this, though. But if you're thinking, all right, inverse cosecant can spit out angles in quadrant 1 and quadrant 4. Inverse cosecant, he acts just like his inverse sine. So his reciprocal, we can convert this. Well, guys, you don't want to put in 0.8 if you think about it. I mean, you could, but you have to flip it over. So it's 0.8 over 1 right now. Because we're using a calculator, you could literally write 1 over 0.8 and be fine. Your calculator's going to do it. We don't usually do that. So technically, either you're going to move this over and then move this over, and it's 8/10, right? Or how do you read 0.8? It's 8/10. So either way, you can convert it, right? But on the calculator, it wouldn't have stopped you from putting in 0.8 over 1 or 1 over 0.8. But guys, do you remember the inverse cosecant? He had a big gap between negative 1 and 1. Those are ratios that were not capable of coming out of his function. Therefore, they were not ratios that you were capable of spitting in. 8/10 is a number in between negative 1 and 1. That's not a good ratio for this function. Maybe you didn't catch it, right? So you're going through the motions. Let's make it the inverse sine of, maybe you wrote 1 over 0.8. Maybe you wrote 10 over 8. Maybe this rings a bell. Hold the phone. You should know that the sine function is only capable of spitting out angles between 1 and negative 1. It's O over H, guys. It's never going to be a number bigger than 1. 10 over 8 is definitely a number bigger than 1. So if you tried to plug this into your calculator, you should get a domain error. This is undefined. You cannot plug a ratio bigger than 1 into the inverse sine. So if you're sitting here thinking like, yeah, it's definitely going to be a quadrant 1 angle. No, it's not, because it's not capable of having that ratio. So if you plug it in, I think it says domain error, because that's not a ratio in its domain. So luckily, the calculator is going to do the thinking for you. So even if you didn't catch it, it'll say, yeah, no, you can't do that. And now you know, all right, it's undefined. All right? So just be careful with what ratios you are trying to plug into some of these. So the answer to this is just undefined. That's a bad ratio. Okay. All right, now let's do some inverse cotangent. How the heck are we going to convert these to inverse cosine, since it can't just be the flip of a fraction anymore? All right, so guys, let's do the first one. If you had to find the inverse cotangent of 1 and 1/2, 1/2 is not a special ratio for the cotangent function. So I can't just draw a triangle or a special triangle and figure out what angle this is. This is going to be some weird angle that's not special. All right, well, think about it this way. What do we know? We know the inverse cotangent is capable of spitting out angles between quadrant 1 and quadrant 2, right? If you take the inverse cotangent of a positive ratio, and he doesn't have bad ratios, remember ratios from negative infinity to infinity survived, he's going to spit out a quadrant 1 angle. We know if the ratio is positive, the answer to this is some quadrant 1 angle. Okay, so guys, if we're going to convert this to cosine, I need a new ratio. I need the cosine ratio for that angle that has a cotangent ratio of 1/2. So what you're going to do, if you know the angle is a quadrant 1 angle, give yourself an angle in quadrant 1. Then draw a triangle off of that angle. We know we were taking the inverse cotangent of that ratio, which means that is the cotangent ratio for the angle we've created. That is A over O. That is X over Y. So I know 1 and I know 2. And if I'm an angle in quadrant 1, this is a positive X coordinate. This is a positive Y coordinate. So I don't have to add any negative signs on my own. You have to now find the cosine of this angle. You have to create a cosine ratio. So guys, a cosine would be A over H, X over R. I need this third side to create a cosine ratio. So a little Pythagorean theorem, A squared plus B squared equals C squared, 1 plus 4 equals 5, and square rooted, it's root 5. Okay, so now let's create the cosine ratio for the angle that has that cotangent ratio. So the cosine of the angle we've just created, x over r, a over h, whatever you want to do, it's 1 over root 5. Don't even rationalize it because we're using a calculator. So guys, if the cosine of this angle gets you that ratio, to find that angle, which is what we're after, just take the inverse cosine of that ratio. So now you'll take the inverse cosine of the cosine ratio that you created. So the angle will equal the inverse cosine of 1 over root 5. And that is still the same angle that had a cotangent ratio of 1/2. But now we have a calculator button that can find it. So take the inverse cosine of 1 over root 5. And again, we said it's a quadrant 1 angle, right? So something between 0 and 1.57, it's 1.11 radians. So for these inverse cotangent problems, you're going to have to build a triangle, you're going to have to create a cosine ratio, and you're going to have to inverse cosine the ratio that you create. All right, let's try another one. Okay, let's say you had to find the inverse cotangent of negative 2/3. Remember, cotangent doesn't have any bad ratios. They're all surviving from negative infinity to infinity. So we know the inverse cotangent is capable of spitting out angles between quadrant 1 and quadrant 2. If you take the inverse cotangent of a negative ratio, we know the answer to this is which one? Quadrant 1 or quadrant 2? Quadrant 2. You know the answer to this is some quadrant 2 angle between 1.57 radians and 3.14 pi. Okay, well guys, if you know it's going to get you a quadrant 2 angle, give yourself an angle in quadrant 2. All right, so that's the angle, but the angle and the reference angle both pass through this point, so we're going to be able to use the reference angle to draw the triangle. All right? Now we have this angle. Guys, I need to convert him to cosine. So I need to create a cosine ratio that I can inverse cosine. So if this was the inverse cotangent, this is the cotangent ratio. A over O, X over Y. X over Y, A over O. Guys, if you're an angle in quadrant 2, you went left and up to make that point. So that is a negative X coordinate and a positive Y coordinate. Got to give the negative to the 2. All right, and then I got to find the cosine of this angle now. Cosine will be A over H, X over R. Guys, I need this number. So a little Pythagorean theorem. A squared plus B squared equals C squared. 4 plus 9 is 13 square rooted. So now we can find the cosine of this angle. The cosine of this same angle who had that cotangent ratio. We're still talking about the same angle. We're just using a different trig function now. The cosine of that angle is X over R, A over H. So negative 2 over root 13. Don't even rationalize it because we're using the calculator. So now the angle itself will be the inverse cosine of that ratio. So now you take the inverse cosine of that ratio that you created, and it should spit out an angle between 1.57 radians and 3.14 radians. Take the inverse cosine of that. Negative 2 divided by root 13. Close catapult. I don't think you have to. And look at that, 2.16 radians, a number between 1.57 and 3.14, 2.16 radians. Okay, I was trying to do the last one before the bell cuts me off. All right, now we're taking the inverse cotangent of negative 2. We know the inverse cotangent is capable of spitting out angles between quadrant 1 and quadrant 2. If you take the inverse cotangent of a negative ratio, you know it's spitting out an angle in quadrant 2. So we know the answer to this is a quadrant 2 angle. That's important because you got to know where to put your triangle. You got to know what quadrant to draw your triangle in. All right, well, guys, I can't take the inverse cotangent of -2. I have to convert this to cosine. So go to quadrant 2 and give yourself an angle that landed there, because that's where we know this angle would be. Draw a triangle off of that reference angle. That's a terrible right triangle. I apologize. All right, that is his cotangent ratio, -2/1. So now A over O, X over R is 2. Oh my God, I pointed there. A over O, X over Y. That's my bad. That's 2 and 1. Guys, who gets the negative sign for a point in quadrant 2? You go left and up, so give it to the negative. And then the same thing. Now create your cosine ratio. So I need my radius, my h. A squared plus b squared equals c squared. 4 plus 1 is 5, and root it. And now you can create a cosine ratio. So the cosine of that same angle, who had that cotangent ratio, has a cosine ratio of -2/√5. And then the angle itself will be the inverse cosine of that ratio. Oh, I don't mean equals. All right, and it should be a number again between 1.57 and 3.14, a quadrant 2 angle.
Does that say the square root of 5?
Yeah, square root of 5. A squared plus b squared equals c squared. Inverse cosine, was it -2 divided by √5? And you get 2.68 radians, which is a quadrant 2 angle. Okay? Do you guys feel okay here? Everybody's good? All right. All right, so everybody at home, are you okay? At least those that would turn their camera on, okay? All right, so you do have a homework assignment on these. I think it's only 8 questions, and it's literally questions just like this. So just be careful whether it says find the exact value, then you don't need a calculator. It should be a special triangle or a special quadrangle angle. And then if it says use your calculator, you're either converting cosecant to inverse sine, secant to inverse cosine, and then the cotangent takes the most work, guys. He's got to be converted to a cosine ratio first, and then you can inverse cosine that ratio, okay? All right, and then I think that's it for section 2. That was only a 3-day or something. All right, let me check the attendance. If you have any questions, please feel free. Otherwise, you are going to be good to go. All right, who we got? And guys, we are going to take one last quiz at some point. I just don't know when. I'm thinking probably one quiz is left, and that's going to be it.